Alright, so we are chunking things up, smaller chunks so things are easier to find. Here's an example of a chart that would have charge on it. We have here something with 10 electrons, 11 protons, and 12 neutrons. So the first thing we say is, what kind of atom is this? Well, it is a 11 protons. We get out our periodic table and we see that something with 11 protons would be over here. Number 11 there is Na, sodium, so we're going to say, well, that's sodium, so we write the symbol. Sometimes if you're working a chart, it just wants the regular symbol and we'd be done, but I want to make what we call a complete symbol here. I want to give it the mass number, the atomic number, and if it has one, a charge. So the next thing I need to do is write down here what the Z number is, what the proton number is, and that's 11. Then up top I want to put the mass number, which is not 12, it's the two together. It's 12 and 11 together, that's 23. So now, in the other day's homework we would be done, but now we got to look at the electrons, we got to look at charge. And so, for the charge, we have to look at the protons and the electrons. Protons are positive, we have 11 of them. Electrons are negative, so we're going to subtract off 10. 11 minus 10 is 1, positive 1, so that would be our charge there. For the next example, 9 protons would be an atom of fluorine. From our periodic table we see that 9 is fluorine, right up there, symbol F. And then we have 9 protons, 10 neutrons, so we have a total mass of 19. And now we say, for the charge, we look at this and we say, well, 9 protons minus 10 electrons is now negative 1. So this is actually going to be an anion, a negative ion. And so we'd write that way. Alright, now if we go the other way, we can look up here and we can see, well, here is this time we have the whole symbol, but we have to figure out the protons, neutrons, and electrons. So we look here and we see, well, the proton number is the bottom number, that's 20, so we're good with that. The neutron number is not 40, it is the difference between the mass number and the proton number, so 40 minus 20 is still 20. And then we get to the electrons. Now we do it exactly the same way, except this time we know the charge and we don't know the electrons. So you got to kind of use the same equation, protons minus electrons equals the charge. We're still going to do that, we're going to still use algebra, but this time we know this and not the electron number. So we plug in what we do know. Proton number is 20 minus the electron number, so you can just kind of call that x if you want, like we would in algebra, and the charge is now positive 2. And so then we say, well, what is x then? Well, x is, we're going to subtract 20 from both sides. We get negative x equals negative 18, or positive x equals positive 18, or that there are 18 electrons. And that makes sense because 20 minus 18 does equal 2. So that would be that. In the final example here we have sulfur. Sulfur is an element number 16, as we see here. So we know there are 16 protons. The neutron number again, mass number minus protons, we get 17 for that. And then for the electrons, we look at the charge again. Protons minus electrons equals the charge, but this time the charge is 0. So now we know the protons minus the electrons equals 0, and therefore the number of electrons must be 16. So that's how we work out atoms, ion charges, based on the number of protons, neutrons, and electrons.